Team 7, we will be presenting the multi-purpose aerial drone project for bridge inspection and fire extinguishing. My name is Raquel Remington, this is Ramon Cordero, Daniel Villanueva, and Larry March. Now our problem statement and motivation would be to produce a new generation quadcopter that will be improving the current design that was produced by an electrical computer engineering team. The configuration of these applications will allow the quadcopter to deliver fire extinguishing grenades without risking the lives of firefighters. It will be able to establish instant aerial surveillance in critical police situations, and it will also allow people to inspect hard-to-reach areas like bridges, power lines, and large road signs. There will be several impacts on safety and economics that will be very important with this quadcopter. For fire extinguishing, it would help to prevent injuries and deaths of firefighters by allowing them to deliver fire extinguishing grenades separate from actually being involved in the fire. Just this year alone, between January 1st and March 7th, there's been 728 deaths from fires, which could have been prevented. There's also last year where 19 firefighters died in the Arizona wildfire. Through police surveillance, this will allow for police officers to get instant aerial view of their critical situations without calling helicopters. And there's also been pretty substantial officer deaths within the past 3 years. Most noted in 2011 where there were 169. This will also allow for the inspection of hard to reach places a little bit easier. You won't actually need a person to be on top of a bridge in scaffolding. You would be able to fly the quadcopter up into these areas. This will also be a little bit cheaper, faster, because you don't have to deal with the safety regulations of the person, and it can help to avoid costly accidents and loss of life.
Good morning. In today's market, the UAV technology is growing very fast, especially in the military, due to all the massive funding they have. They use now some of the drones for combat and also for to do recons and different types of missions. In the civilian side, there's also a lot of technologies, but some of is being regulated by the FAA. And some of the major manufacturers are Boeing, Lockheed Martin, also the Aero Vermin with the Hummingbird, with the development of Hummingbird. Plus Dynamics also with some of the developments as far as the Black Hornet Nano, and some of the other ones would be Israeli aerospace industries and texture.
Compatibility, some of the issues right now is it's 60 hertz to charge, but it's easy to solve. You get an adapter, so you can charge it in different countries where it's 50 hertz. Also, every country has a need for infrastructure inspections, of course. Everybody has bridges, power lines, etc. So it's lithium battery powered, which is recyclable at certain plants. Carbon fiber, the frame is made out of carbon fiber already, and that's recyclable and reusable at the same time. The parts could be disassembled and used for different projects as well.
Alright, so our design objective is basically to use 3 different types of cameras. That's going to be the low resolution camera, which will make it easier to transmit live footage to a computer. Also a high resolution camera, which will take better picture quality, and thermal infrared camera for inspection. We also want to implement proximity sensors for safety reasons. We want to make sure that our quadcopter does not collide with any other objects. And our release mechanism is a little bit different from the previous senior design. The previous senior design didn't use a spring mechanical system, which threw the ball in part-time motion, which caused the entire quadcopter to become unbalanced. What we're going to be doing is just dropping the ball in a vertical downward motion. This is our first design alternative. Basically, it's the quadcopter model. On top is the camera installed. This camera must revolve about the z-axis, and also the release mechanism on the bottom is a robotic arm. Basically, it will compress the ball just enough so it won't explode it, and then through a remote signal, it will release it. And this is our last design alternative, our second one. It's basically the same model. The only difference is that the release mechanism is a bit larger, and the reason being is that we want to put more than one ball so that it can release 2 balls. And the way that this release mechanism works, it uses a stepping motor that will be programmed to rotate about a certain angle, and the first ball will be released, and then it will rotate back just on time to take the other ball before it falls down.
Any questions?
Are you gonna build one of these? Is that what the project is between now and the fall? To actually build a helicopter right from scratch, or are you gonna buy one that's?
They've already built it. The quadcopter is built, the framework and everything. What we're going to be doing is redesigning the throwing mechanism and possibly adding on a couple of cameras more.
A previous group did that
Yes.
last
Right,
year.
right.
Yeah, I remember
I wondered if they were gonna build their own,
Well, they built their own. It was the previous groups have built it from scratch.
so you're gonna design and build the launch mechanisms.
Right.
What's a grenade anyway, a firefighting grenade?
They make these little balls. They're roughly about this size, and they contain like a powdered fire extinguisher that you can sometimes see in certain types of actual fire extinguishers, the normal sized ones. But this one is roughly 1.5 kilograms, and it's smaller.
You know, as it gets close to the ground, does it blow up? Or?
Yeah, it detects the fire as it gets closer to the ground, and it'll blow up.
It takes
Pretty
about
close.
about 70 degrees for it to reach, sense that temperature, and then it will blow up after 3 seconds.
Is there a shockwave involved with that or anything like that, or that move around your helicopter when it explodes?
You should be high enough so that if there is a shock wave.
Well, you're talking about dropping that in a room, right? Or where you think, what's the application on that?
It would be small fires, because the issue with larger fires is you have a massive updraft, and the quadcopter would not be stable as of now to release something in a larger fire. But these grenades don't produce shock waves enough. The main issue right now is when the quadcopter tosses the ball, it's not very stable flying yet, so it crashes anyways just by
Single
throwing
use
it.
right now?
And another thing is, if you look at the second design, basically this one of our motivations was also the 9/11 event. Basically, we feel that our quadcopter could have reached those people faster than the firefighters who had to go through all the traffic. I mean, if it's possible to possibly put like two of these fire extinguisher grenades inside, and then possibly put inside the window, and then because when the event happened, a lot of people were leaving those. So if we could have brought those in there and they could have gotten and thrown them, possibly we could have saved.
Well, that stuff was a fuel fire with huge, so I don't know if a grenade would have helped there, but do you know how much fire
Like
retardant is allowed by those grenades?
6
About-
cubic meters.
6 what?
Cubic meters.
So where are your cameras going to be located? I see only one.
As of now, the current design has only one located on it. We haven't really decided exactly where we're gonna locate, 'cause we need
How do you see where you drop the bomb?
Obviously.
With
we
a
would-
camera mounted on top like that?
Right, obviously we would have to have a camera on the bottom.
A
to
bomb
get
bay camera.
surveillance.
Okay. And then the other question I had is on payload. Do you know what the maximum capacity of this drone is to payload?
5 kilograms.
So this whole system, everything that you're doing has to be able to weigh less than 5 kilograms?
Right, with the exception of the actual quadcopter. The quadcopter itself can lift 5 kilograms on top of the current throwing mechanism and the current camera that is on it. So we can lift 5 kilograms worth of either adding more cameras on or multiple fire.
So do you know if this design, your alternative 2, will meet that requirement?
Not yet.
If anything, we're probably gonna have to cut it in half.
How much of those bombs weigh?
1.5 kilograms.
So you've got 3 kilograms out of the 5 kilograms being used just on
Yeah.
carrying 2.
Right,
That's your biggest design
Yeah,
concern.
that's what we-
yeah.
Titanium, like titanium.
And that's a big drop. When you drop one, that thing will take off.
Yeah, and that's the other comment is that,
You know,
it's stability of the system. When you drop one, you just dropped about
half the weight, yeah.
your weight.
Maybe they could automate that, with programming. We'd probably automate that, but How about navigation on that? I know that's not your side of the project, but how do you navigate? Is it GPS enabled or is it just visual?
It's actually just like a, kind of like an RC plane that has the remote control.
So it's visual.
And how you encounter cinders and things like that.
We haven't taken that into account yet.
Are you gonna make the mechanism for this?
Yes,
So you're gonna set a weight standard for each component?
yes.
It's kind of fun if you do the machining yourself. You know, you have a little scale next to it. We made some gears.
Oh, yeah.
Going to a Mars flyby, and there was a weight, the machinist machined it, and then put it on a scale, oh, that's not enough, and you machined a little more, that's not enough. Drilled some holes in it, whoop, that's not enough.
That'll work.
Eventually, we got it to where it had to be in its weight, and the weight was very, very critical.
Right.
So you could do something, you could have a lot of fun doing that.
Oh, yeah, definitely. Any other questions?